What do you know about X-rays? We all know they are used to take pictures of your bones or to see the contents of your bag at the airport. But have you ever imagined that a very powerful source of X-rays could also help solve industrial problems and could help speed up your innovation process? Well, yes it can, and the ESRF does it. A wide range of techniques is open to industry at the ESRF. Dr. Gemma Martinez Criado, beamline responsible, will give us an insight into X-ray fluorescence spectroscopy.
X-ray fluorescence analysis is a technique commonly used at the ESRF for chemical composition analysis. The idea is to get the elements, the major and trace elements in a sample. So most of the cases we apply the technique to mummies, to fly edges, to anything in a tiny sample or in a homogeneous distributed sample. Like, for instance, metallic particles in solar cells, in devices like for microelectronics, optoelectronics, or spintronics. So very oriented to localization of elements that they are at very low quantities. X-ray fluorescence applications can be divided in 5 big groups: art and archaeology, like paintings, mummies; air and environmental science for residual products, decontaminations, etc.; material science, like microelectronics, nanotechnology; biomedical applications like cells, neuron, prostheses; and finally geology, like hydrothermal processes in ancient times, precipitation, etc. The principle behind the technique is basically the X-ray absorption. So we collect the light as a secondary process of the X-ray absorption, and we analyze by energy. Like this, we are able to determine which elements are in the sample. The micro X-ray fluorescence setup is basically consists of 3 elements: the source, the focusing element, and the sample state. Basically, we scan the sample in the beam and we collect in a pixel by pixel basis each spectrum, fluorescent spectrum for each point. From that spectrum, we build elemental maps with the composition of the different elements. Like this, you are able to co-localize the different elements on 2D. If necessary, sometimes we can collect simultaneously the X-ray diffraction data. Like that, we have not only the composition, but the structural analysis at the same time. So in the end, what we get is both composition and structure spatially resolved. X-ray fluorescence analysis compared to electrons or particle-induced techniques have plenty of advantage. One of them is the large penetration depth, which gives more than a surface sensitivity. A second one is the detection limits that can reach ppb levels. Non-destructive, we don't need to section the sample, so you can get it as grown and to bring it here. In general, we have a large dynamic range. When I say that we go from ppb to 100%, we can cover the full range of intensities. And we have the advantage of elemental selectivity. We can tube the energy in the full energy range to detect different elements. Sample size can be studied according to the user need, from centimeters, millimeters, down to nanometer scales. We have 2 stations, one with a micrometer beam size and a second one with a nanometer size. So, in principle, up to 50 nanometer samples can be accommodated and be studied with the X-ray beam. In general, we can study samples in different environments, different temperatures, pressures. Semiconductor industry needs to couple different devices in a single chip. That's why they want for instance, to use for optical fiber communications at higher speeds and lower price, to couple a modulator and the laser in the very single chip. To check whether the formation of this chip is okay or not, we have been working on the X-ray fluorescence analysis of the wafer. X-ray fluorescence maps allow us to study the spatial variation of the indium, gallium, and arsenic elements all over the wafer, while X-ray diffraction patterns collected simultaneously allows us to study the structural order for both devices and the formation of both modulator and laser at the same time. X-ray fluorescence analysis can help you to analyze the chemical composition of your sample with high spatial resolution down to nanometer scales at trace levels, ppb.
If you're interested to know more or to find out how the ESRF can help your business, please contact Dr. Edward Mitchell, our Business Development Manager, or visit our website